Good morning, children. So again, welcome back to the online session of the physics class. So we are discussing about the force and pressure lesson. So in that lesson, we are discussing about the force. Okay. So last class I have given the explanation about a brief introduction about the force. And force will be a push or pull on an object is nothing but a force. So that will be the definition for force. And we can't able to see the force, we can able to see the effect of the force. So we have so many situations like hitting the ball or kicking the ball or flickering the ball and then lifting the water from the well, then pushing the door, opening the shutter, closing the door. So all these actions you can either bring it to push or pull. So overall a push or pull on an object is nothing but a force. So that we have learned in the last class. So in this class, let us learn about forces are due to an interaction. So when the forces comes into play, when the force will be exerted. So if I am having only one object, can be able to exert the force or they can be able to see the effect of the force only on one object. If there is no interaction between only this object, I'm just keeping that object, okay. So is that can be able to see the effect of force, can be able to see the effect of force on an object without interaction with any other objects? No. The answer is no. Reason is forces are due to interaction. We need at least two objects. We need at least two objects. If I want to see the force, force will come to play, force is exerted only when two objects are interacting. If the there is no, at least we need at least two objects. At most we can have more than 2-3 objects will be there, but minimum we should have two objects to exert the force. Now, if I apply the force on this duster in the sense, that means the two objects will be, one will be me and another one will be the duster. So there will be two objects, right? So these two objects will be interacted. So then only we can able to see the effect of force. The effect of force is the duster is moving. It will be this changing state of motion, right? From rest to it is moving, right? So what is the first one? At least we need two objects must interact for a force to come into play. Keeping only one object, we can't be able to see the effect of force. Force is not exerted by having only one object. So we need at least two objects must interact. Those two objects also must interact. If you are keeping only two objects in the sense, they are not interacting in the sense, then also force is not exerted. They have given a beautiful example in the textbook. You can observe this. You can able to see this, you can observe this. See, forces are due to interaction. See, there is a vehicle, car, there is a person behind that. So both the vehicle is standing over there and he is also standing over there. Their force is not exerted. So observe the next picture. A car is being pushed by a man. Those two objects are going to be interacted. So therefore force is exerted over there. Okay. So here who is pushing whom? Again, both are pushing each other. Right? Here both are pulling each other. You can observe these two pictures. Here, who is pulling whom? So he is pulling the cow, right? So these are the pictures, forces are due to interaction. So what is the conclusion? What is the conclusion we have taken from this point in the sense, from these pictures in the sense? Forces will be exerted only when two objects are interacting. At least two objects are interacting. At most, there will be more than two objects, maybe interaction will be there. But to exert a force, to experience a force, we need at least two objects. So that is about the conclusion from the first forces are due to interaction. Okay. So next. So thus the interaction of one object with another object results in a force between the two objects. So there should be an interaction with each other. If there is no interaction also, there is no force exerted. So there should be an interaction. If there is an interaction between those two objects, there will be a force between those two objects. Okay. So that is about forces are due to interaction. Next we are having exploring forces. exploring forces. Here, force, when it comes to matter of force, right, I can push in this direction also, or I can push in opposite direction also, right? So what will happen if I see, I want to push this table from this place to that place, okay? Assume that this table is heavy, I can't able to push this table, okay? What I will do, I will call my friend also to push this table. So we both will push this table. So it will be easy for us. Now assume that I will be pushing on this direction. My friend will be pushing in the opposite direction. What will happen? The table will move. Of course, the table will move in which direction? In the sense, who is applying more force, right? If I apply more force, then that will be moving in that direction. If he is applying more force, then that will be moving in this direction, right? So that is the thing we know that naturally we know that. So what happened if I apply the force on one direction, if I apply the force on the opposite direction? So that is about exploring forces. Now, forces applied on an object in the same direction, and one to another. Now I will be applying some force, my friend is also applying some force, we both are applying some force, that means both the forces will add up each other, both will add up by each other, the net force will be the added force, right? So that's why the table is moving. If myself is only applying a force, the force is very less, so we can't able to move that table, right? So he is also coming and he is also adding some force, so my force and his force both will be added up, okay? So the table is moving, correct? So that is the first point. Forces applied on an object in the same direction, add one to another, so that force is going to be adding each other. So the net force will be increased, so therefore the table is moving, okay? If I am applying on the same direction, if me and my friend will be applying on the same direction, okay? Now, if the forces acting in opposite directions, that means I am applying in one direction, my friend is applying a force on opposite direction to me. So what will happen? The net force acting on it is the difference between the two forces. The net force is difference between the two forces. Difference in the sense, I am applying some force, he is applying some force, right? If both we are applying the same force, the table will not move, right? If I am applying less force and he is applying more force, so what will happen? There will be a difference, right? You can able to find the difference between these two forces. So therefore, the table will be moving towards me because he is applying more force. I am applying less force. If I am applying more force and he is applying less force, then table will be moving towards him, right? So what will happen with the net force in the sense? So net force will be the difference between the two forces. Difference of my force and my friend force. So that will be the net force. So that is about the next point. Okay. So these are 2 points we are going to remember: the exploring forces, and this one part will be forces of interaction. Okay. So now, how to measure the strength of the force? How to measure the strength of the force? The strength of the force can be measured whether the force is weak or otherwise the force is it is having strong. How to measure the strength of the force? Strength of the force can be measured. Strength of the force can be measured by its magnitude. Okay? Magnitude. The strength of the force can be measured by its magnitude. Hope you have learned what do you mean by magnitude. Magnitude in the sense, the numerical value of the physical quantity. Now, For example, if I take it for distance, say suppose I am taking for distance, okay, from school to your home, there is some distance, right? So let me take that 500 meter, right? There is some distance between school and your home, right? So let me take 500 meter. That will be equal to the numerical value, right? 500. That is nothing but the magnitude. That is nothing but the magnitude in the physics. So this is physical quantity. Magnitude. Meter is the SI unit. That is the unit. Every physical quantity is having its own unit, standard unit. Okay. So this is the SI unit. SI unit of distance. Similarly, strength of the force can be measured by its magnitude. You can write it exactly what is the magnitude. It is numerical value. This numerical value of the physical quantity. Numerical value. So, how to measure the strength of the force, whether the force is weak or force is strong, by measuring the magnitude. By measuring the magnitude. So, we can able to find out the force. Suppose I am having a force, force of an object, force on an object, force on an object A is 50 Newton N. Then I'll tell you what is N on an object B is 100 N. So what is 50 and 100? 50 is the numerical value, 100 is the numerical value, which is nothing but a magnitude. Magnitude of the force. Magnitude of the force. Now, which is having strong and which force is strong and which force is weak? Obviously, the force is applied on object B is strong, right? The force is applied on object A is weak. So, we will come to know that which is weak and which is strong. By knowing the value, by knowing the numerical value, by knowing the magnitude, by knowing the magnitude of the physical quantity, we can measure the strength of the force. We can measure the strength of the force. Okay? So the strength of the force can be measured by its magnitude. So how we can able to measure its strength? By taking an example I explained you. Okay. Now let us learn what is the N. N is nothing but Newton. N is nothing but Newton, which is the SI unit of force. The SI unit of, so if this is as a point and this is a point. The SI unit of force is Newton, denoted by capital N. So, whenever we are saying that how much force you have applied, that means you should tell me the numerical value. I have applied 12 Newton. I have applied 20 Newton. So, I should say that numerical value, that is magnitude, as well as the SI unit. How much distance you have traveled? I have traveled 500 meters. So, you should say that magnitude as well as the SI unit. If I say that I have traveled only 500, what is 500? Either 500 meter or 500 centimeter or 500 kilometer, what is that? Right? It will not give a proper meaning, right? So, standard unit is very, very important. SI unit is very, very important. If you change the SI unit, the whole meaning is going to be changed. So, there will be a difference between 500 meter to 500 kilometer, right? If you write only 500 meter, then I should specify that whether it is 500 meter or 500 kilometer, right? If I write meter, which is different. If I write kilometer, then that is totally different, right? So, therefore, the SI unit is very, very important for any of the physical quantity. So, for the Newton, for the force, the SI unit of force is Newton. So, that will be force will be denoted by, force is denoted by F. Force is denoted by F. In fact, it is having a particular direction. So, you have one more thing that our physical quantities